Welcome. Today we're going to be talking about the areas of parallelograms and triangles. As we get started, we're first going to talk about a rectangle, which is of course a specific type of parallelogram. It's one which has 4 right angles. The formula for the area of a rectangle is base times height. This is slightly different from what you're used to in terms of length times width, where we would typically call this the length. Now we're going to call it the base. We would typically call this the width. Now we're just going to call it the height. Other than that, the process is the same. When we talk about parallelograms in general, the formula is also base times height. And the reason is this. If I were to draw in the altitudes, if I draw in this height and this height, basically what I've drawn is the sides to make this a rectangle, this shape right here. And that distance, if I consider this to be my base, this to be my height, that's the area of that figure. Well, what we know, because opposite sides of a parallelogram are congruent, and because the distance between parallel lines is the same, we have 2 congruent triangles, this triangle and this triangle, which means if I were to cut this shape out and move it over here, basically I have a rectangle, which is why we can use area equals base times height for the area of a parallelogram. So let's do a couple of examples. Example number 1, we're finding the area of a parallelogram, so we're going to do base times height. In this problem, this is going to be my height, which is 3.5 centimeters because it's perpendicular here. And it's perpendicular to this distance, which means this is going to be my base. Don't let this number draw you in. It's superfluous. We don't actually use that information. So my base is 2, my height is 3.5, so we have area equals 7. My unit is centimeters, and area is always square units, so we have centimeters squared. For number 2, we're not given extra information like we were in number 1, so we just simply need to plug in what we have. Area is base times height, and this tells us the parallelogram has a base of 12 meters and a height of 9 meters. So if we multiply those two, we get 108, and our unit is meters squared. Okay. One more example that's a little more in depth in terms of the process. For this parallelogram, we want to find DE to the nearest tenth, and DE is right here. Well, it's a height, so the way to find a height is if I have the area, but it doesn't give me the area. What I know is that this is the height to this base. I also have this base with this height. So if first I use that to find my area, and I have a base of 13 inches times a height of 9 inches, so I have 135 square inches as my area. Then I can use that, again going back to the same formula, to find my missing height. So my area is 9.4 times that missing height. If I divide both sides by 9.4, we do 135 divided by 9.4. It says to round to the nearest tenth because we're not going to get a nice pretty whole number. So we get 12.4. Now this is going to be in regular inches, not square inches, because we're just looking for the height. So even if we're looking for a missing figure, if I know the area, then I can use that to find one of the other 2 dimensions. Now a triangle, the area for that is based off of a parallelogram, because if I take a parallelogram and split it in half by drawing in the diagonal, then I have 2 congruent triangles here, because these 2 sides and these 2 sides are congruent. This diagonal, of course, is congruent to itself. So if I consider this triangle 1 and triangle 2, then I know that triangle 1 is congruent to triangle 2, which means they're going to have the same shape, same size, same area. So to find the area of one of them, I simply take the area of the entire parallelogram and multiply it by 1/2. And so this becomes the area of my triangle. Now most of us have worked with area of triangles before, so we're going to do a problem that requires a little bit more than just finding the area. In this one, you want to make a triangular sail like the one at the right over here. You are ordering the fabric from an online retailer who charges $9 per square foot, 6% sales tax, and $5 shipping. How much will it cost you to purchase the fabric? Now I know you don't pay tax on the shipping, so we're going to compute the tax before we add in the shipping cost. Now what I need to do first is find the actual area of my sale. Now the height in this one, we have 12 feet 2 inches, but I can't use mixed units. I need to change that to all 1 unit. So to make it easy, let's change it all to inches. If I change it to inches, 12 feet is 144 inches. I add in my 2 inches and I get 146 inches for my height. Now my base is 13 feet 4 inches. Again, we're going to convert this. 13 feet is 156 inches. Add in my 4 more and I have 160 inches. And now we're going to use our formula to find the area of my sail. It's 1/2 base times height, so we have 1/2 times my base, which is 160, times my height, which is 146. If we do that multiplication, 1/2 times 160 times 146, we get 11,680, and that's in square inches. But my online retailer charges by the square foot, so I need to change this to square feet. Now if we think about 1 square foot, if we look at this figure, this is 1 square foot, right? It's 1 foot in this direction, 1 foot in this direction, and those two are the same. Well, if I think about 1 square foot in terms of inches, I have 12 inches here, I have 12 inches here. So that gives me 144 square inches, which means in order to change this to square feet, I need to divide it by 144. If I do that, it's not going to be a whole number. I'm going to get 81 1/9 in terms of square feet. I'm going to leave it as a mixed number. Now let's find out how much all of this is going to cost me, because here's my area. How much is this fabric going to cost me? So I have 81 1/9 square feet, and I'm being charged $9 a yard, and I have to pay a sales tax of 6%. Now the easiest way to do that in order to be able to figure it all at once is to multiply times 1.06. What this does is it multiplying by 1, you've got your actual cost, and then adding the 6% sales tax on that. So it does it all in one step for you. So if we multiply this out, we get $773.80. But remember, we've got to add on our $5 shipping. So we add $5 shipping in there. We have $778.80. Hopefully I don't mess up when I'm making my sale, because that's an expensive sale. Okay. Another example here, we now have an irregular figure. This is not a nice pretty figure where we have just one shape. We actually have 2 shapes. So what we're going to do is find the area of each shape individually and then add them together. So if I start with one shape, which is a parallelogram, remember the area of a parallelogram is base times height. This parallelogram has a base of 15 centimeters, a height of 21 centimeters, so we're going to do 15 times 21. So we have 315. Now we have centimeters, so my unit is centimeters squared. For the second figure, it's a triangle, so we're going to do the area of a triangle, which is 1/2 base times height. The base of my triangle is 20 centimeters. Now they don't have the height drawn in, but it's this here, which, because the triangle starts from the top of my parallelogram and goes to the bottom of my parallelogram, is the same as the height of the parallelogram. So we have 1/2 times a base of 20 times a height of 21. So we get 210 centimeters squared. So the area of my whole figure, I'm going to call it IF for irregular figure, is 315 plus 210 We add those two together, we get 525 square centimeters. And that is the area of that figure. One more problem to go through. Now we're going to use a coordinate plane. We want to find the area of the polygon with the following vertices. So as I'm sure you're aware, we're going to start by graphing, and I'm going to graph here's point E, and then we're going to have point F, and point G, and point H. It's at 8, 1. Okay. Now this looks like a parallelogram, but we're not going to go with just what it looks like. We're actually going to verify that it's a parallelogram, and we're going to do that by checking the slopes. Now if I look at the slope of this side, it's horizontal, so we know that's slope of 0. This side also is horizontal, is a slope of 0. Now these two sides are not horizontal or vertical, so we actually have to find their slopes. And remember, we can do rise over run. So if I look at the slope of GH, to go from H to G, I go up 4 over 3, so we have a rise over run of 4/3, and it's a positive slope because it goes up as I'm going to the right. If we look at EF, to go from E to F, I go up 4 and over 3, so I also have a slope of 4/3. Since my opposite sides are parallel because they have the same slope, that means I do have a parallelogram. So I can use my formula of base times height, but I need to find the base and the height. Let's think EH as a base. Since it's horizontal, I can just count the boxes. So going from E to H, I notice that my base is 7. And now I need to find my height of vertical distance, and since it's directly vertical, we can just count the boxes from the top to the bottom, and we get 4 boxes. So my base times my height is 7 times 4, which is 28. Now since I'm on a coordinate plane, I'm not given any units, but I still need to put something down because it's not just 28 as a number. Since I don't know what the units are, I simply say it is units squared. So we have 28 units squared. And that's how we find the areas of parallelograms and rectangles. I hope you've enjoyed this. Check in next time for trapezoids, rhombuses, and kites.